Hello students, welcome to this lecture one number systems. So in this lecture we will discuss exercise 1.4 and exercise 1.5. Okay, so let's get started. In question number 1, here we have to classify the following numbers as rational number or irrational number. Okay, so in first one we have 2 minus root 5. So what type of number is this? So 2 minus root 5, this is actually you can write 2 minus 2.2360679, that is equal to minus 0.2360679, as the decimal expansion of this expression is non-terminating and non-recurring. Okay, so therefore it is an irrational number. So 2 minus root 5, this number is actually a irrational number. And now let us check second one. So in second one, here we have 3 plus square root of 23 minus square root of 23. Okay, so first let us simplify this number. So here 3 plus square root of 23 minus square root of 23, that is actually equal to 3. Okay, and you can write it as 3 by 1. So now this number is of the form p over q, where p, q are integers and q does not equal to 0. Okay, therefore it is a rational number. It is a rational number. So this number 3 plus square root 23 minus square root of 23, this number actually a rational number. And now let us check third one. So in third one, here we have 2 times root 7 divided by 7 times root 7. Okay, so let us check which type of number is this. Okay, so we have here 2 times root 7 divided by 7 times root 7. Okay, and here you can cancel root 7 and root 7, because root 7 is common in numerator and denominator. So here root 7 will cancel and we'll get this is actually equal to 2 by 7, which is of the form p over q, where p, q are integers and q does not equal to 0. Okay, therefore it is a rational number. So in third one we have this number 2 times root 7 by 7 times root 7, and here we could able to write this number as 2 by 7, which is a rational number. Okay, now let us check fourth one. So in fourth one, here we have 1 by root 2. Okay, so let us check which type of number is this. So here we have in fourth one 1 by root 2. So 1 by root 2, this can be written as root 2 by 2, root 2 by 2, and the decimal expansion of this number is basically equal to 0.7071067811 ... So this is the decimal expansion of this number. Okay, and here as the decimal expansion of this expression is non-terminating and non-recurring. Okay, therefore it is an irrational number. So this number 1 by root 2 is an irrational number. Now let us check fifth one. So in fifth one, here we have 2 times 5. Okay, so we have studied in our previous lecture, pi is an irrational number. Okay, so pi is an irrational number. So 2 times pi, this is also an irrational number. Okay, obviously this is also an irrational number. So you can write 2 pi. This is actually equal to 2 times 3.1415 ... Since pi is equal to 3.1415 ... Okay, so the decimal expansion of pi is equal to actually 3.1415 ... And this decimal expansion basically is non-terminating and non-recurring decimal expansion. Okay, so now 2 times the decimal expansion of pi, this is actually equal to 6.0 2830 dot dot dot. Okay, as the decimal expansion of this expression is non-terminating and non-recurring, therefore it is an irrational number. Okay, so 25, this is also an irrational number. So among these 5 number here, in first one, which is actually an irrational number, and second one is rational number, third one is also a rational number. Okay, and fourth one, 1 by root 2, this is actually an irrational number. Okay, and 2 by, this is an irrational number. So the following numbers as rationals or irrational number. So among these, this is irrational, this is irrational, and this is irrational. And here this number and this number, they are rational number. Okay, so now let us move to the next problem. So in next problem here we have to simplify each of the following expressions. Okay, so we have given some expression and then we have to simplify them. Okay, so let us see how to simplify them. So in first one here we have 3 plus root 3 times 2 plus root 2. Okay, so let us simplify it. So 3 plus root 3 times 2 plus root 2, that is equal to actually 3 times 2 plus root 2 plus root 3 times 2 plus root 2, and then this is equal to actually 6 plus 3 times root 2 plus 2 times root 2, 2 times root 3 plus root 6. Okay, and this is actually the simplification version of this expression. Okay, so if we simplify the expression 3 plus root 3 times 2 plus root 2, then we will get this is equal to 6 plus 3 times root 2 plus 2 times root 3 plus root 6. Okay, so now let us see next one. So in next one here we have 3 plus root 3 times 3 minus root 3. Okay, so let us simplify it. So here in second one here we have actually 3 plus root 3 times 3 minus root 3, and in our previous lecture there we have studied about this identity a plus root b times a minus root b, that is actually equal to a square minus b. Okay, so if we apply that identity for simplifying these expressions 3 plus root 3 times 3 minus root 3, then we will get this is equal to actually 9 minus 3, and that is equal to 6. Okay, so after simplifying this number 3 plus root 3 times 3 minus root 3, then we will get this is equal to actually 9 minus 3, and this is equal to actually 6. Okay, so now let us see third one. So in third one here we have root 5 plus root 2 whole square. Okay, so we have studied in our previous lecture how to expand root a plus root b whole square. Okay, so we know that identity. So now if we use that identity here, then we will get this is actually equal to root 5 plus root 2 whole square. This is equal to root 5 whole square plus root 2 whole square plus 2 times root 5 into root 2. Okay, and this is equal to actually 5 plus 2 plus 2 times root 10, and this is equal to 7 plus 2 times root 10. Okay, so root 5 plus root 2 whole square, this is equal to 7 plus 2 times root 10. And then let us see fourth one. So in fourth one here we have root 5 minus root 2 times root 5 plus root 2. Okay, so here we can use the identity root a minus root b times root a plus root b, that is actually equal to a minus b. Okay, so if we use that identity here, then we'll get root 5 minus root 2 times root 5 plus root 2 is equal to root 5 whole square minus root 2 whole square, and this is equal to 5 minus 2, and this is equal to 3. Okay, so after simplifying, root 5 minus 2 times root 5 plus root 2 is equal to this is equal to 3. Okay, so I hope it is clear to you? Okay, so now we can move to next question. So let us move to next question. So in next question here we have this. Okay, so here we have to recall pi is defined as the ratio of circumference of a circle to its diameter, say d, and that is pi is equal to c over d. Okay, and this seems to contradict the fact that pi is irrational. How will you resolve this contradiction? Okay, so here we use this expression pi is equal to c by d. That is actually pi is equal to 22 by 7. Okay, and here actually we express the number pi in the form p over q, where p, q are integers and q does not equal to 0. Okay, so this basically contradicts the fact that pi is irrational. So how will you resolve this contradiction? So let us see how we will resolve this contradiction. So there is no contradiction basically. Why? When we measure length with scale or any other instrument, we only obtain an approximate rational value. Okay, so we never obtain an exact value. For this reason, we may not realize that either C or D is irrational. Therefore the fraction C over D is irrational. Hence, phi is irrational. Okay, so there is no contradiction. Basically, this is when we measure a length with scale or any other instrument, then we only obtain an approximate rational value. We never obtain an exact value. Okay, for this reason, we may not realize that either C or D is irrational. Therefore, C over D, that is actually phi, this fraction is irrational. Hence, pi is irrational. Okay, so now let us move to next problem. So in next problem, here we have to represent square root of 9.3 on the number line. Okay, so let us represent this. So here we have to represent square root of 9.3 on the number line. So let us see how to represent it. So first of all, mark a line segment and OB that is equal to 9.3, one number line, and further take BC of 1 unit and find the midpoint D of OC and draw a semicircle 1 OC while taking D as the center. Okay, so draw so after drawing this, the perpendicular to line OC passing through the point B, and it intersects semicircle at E and taking B as center and B as radius. Okay, so then you can represent square root of 9.3 on the number line. So now let us move to the next problem. So in next problem, here we have to rationalize the denominators of the following. Okay, so let us see here. In first one we have 1 by root 7. Okay, so first one we have 1 by root 7. So 1 by root 7 can be written as 1 into root 7 by 1 into root 7, that is equal to actually root 7 into root 7, that is equal to root 7 by 7. Okay, and then 1 by root 7 minus root 5 root 6. So if we rationalize it, then we will get root 7 plus root 6 divided by root 7 minus root 6 into root 7 plus root 6. Okay, and this is equal to actually root 7 plus root 6 divided by 7 minus 6. Okay, and that is equal to root 7 plus root 6. And if we rationalize it, then we will get root 5 minus root 2 divided by root 5 plus root 2 into root 5 minus root 2. That is equal to root 5 plus minus root 2 divided by 5 minus 2. That is equal to root 5 minus root 2 divided by 3. Okay, and if we rationalize it, then we will get this is actually equal to root 7 plus 2 divided by root 7 minus 2 into root 7 plus 2, that is equal to root 7 plus 2 divided by 7 minus 4. Okay, and this is equal to root 7 plus 2 divided by root 7 plus 2 divided by 3. Okay, so now let us discuss exercise 1.5. Okay, so in first question here we have to find 64 to the power 1 by 2 and then 32 to the power 1 by 5, and then 125 to the power 1 by 3. Okay, so 64 to the power 1 by 2, that is actually equal to 2 to the power 6 to the power 1 by 2. Okay, and we know this formula, a to the power m whole to the power n, that is equal to a to the power m n. Okay, so 64 to the power 1 by 2, that is equal to 2 to the power 6 to the power 1 by 2, and this is equal to 2 to the power 6 into 1 by 2, and this is equal to 2 to the power 3, and this is equal to 8. And then second one, we have 32 to the power 1 by 5. So 32 to the power 1 by 5 can be written as 2 to the power 2 to the power 5 to the power 1 by 5. That is equal to 2 to the power 5 into 1 by 5. Since a to the power m whole to the power n, that is equal to a to the power mn. Okay, so 32 to the power 1 by 5, this is equal to 2 to the power 5 whole to the power 1 by m, and that is equal to 2 to the power 5 into 1 by 5, and this is equal to 2. And 125 to whole to the power 1 by 3, and that is actually equal to 5 to the power 3 whole to the power 1 by 3, and this is equal to 5 to the power 3 into 1 by 3, that is equal to 5. Okay, and now let us see question number 2. So in question number 2, here we have to find 9 to the power 3 by 2, 32 to the power 2 by 5, 16 to the power 3 by 4, 125 to the power 1 minus 1 by 3. Okay, so let us see the answer. So first one, we have 9 to the power 3 by 2. So 9 to the power 3 by 2 can be written as 3 to the power 2 whole to the power 3 by 2. That is equal to 3 to the power 2 into 3 by 2, that is equal to 3 to the power 3, and this is equal to 27. Okay, and 32 to the power 2 by 5, that is actually equal to 2 to the power 5 whole to the power 2 by 5, that is equal to 2 to the power 2 to the power 5 into 2 by 5, that is equal to 2 to the power that is equal to actually equal to 2 square, and this is equal to 4. And then 16 to the power 3 by 4, 16 to the power 3 by 4, that is actually equal to 2 to the power 4 whole to the power 3 by 4, and that is equal to 2 to the power 4 into 3 by 4, and this is equal to 2 to the power 3, and this is equal to 8. And 125 to the power minus 1 by 3, that is equal to 5 to the power 3 whole to the power minus 1 by 3, and this is equal to 5 to the power minus 3 into 1 by 3, and this is equal to 5 to the power minus 1. Okay, and this is equal to 1 by 5. Since we know a to the power m, this is equal to 1 by a to the power m. Okay, and now let us move to the next problem. So in next problem, we have to simplify 2 to the power 2 by 3 into 2 to the power 1 by 5. Okay, so here we can use this formula, a to the power m into a to the power n. This is equal to actually a to the power m plus n. Okay, and here we have 2 to the power 2 by 3 into 2 to the power 1 by 5. That is equal to 2 to the power 2 by 3 plus 1 by 5, and this is equal to 2 to the power 10 plus 3 by 15, and this is equal to 2 to the power 13 by 15. Okay, so 2 to the power 2 by 3 into 2 to the power 1 by 5, this is equal to 2 to the power 13 by 15. And now let us see next one. So in next one, here we have 1 by 3 to the power 3 whole to the power 7. Okay, so 1 by 3 to the power 3 whole to the power 7, this is equal to actually 1 by 3 to the power 3 into 7. Since we know a to the power m whole to the power n, that is equal to a to the power m n. Okay, so this is equal to 1 by 3 to the power 21. And since we know this formula, 1 by a to the power m is equal to a to the power minus m. Okay, so this is actually equal to 3 to the power minus 21. And now let us see next one. So in next one, here we have 11 to the power 1 by 2 divided by 11 to the power 1 by 4. Okay, so we know this formula, a to the power m divided by a to the power n, this is equal to a to the power m minus n. Okay, so here if you use this formula, then actually we get this is equal to 11 to the power 1 by 2 minus 1 by 4. And this is equal to 11 to the power 2 minus 1 by 4, and this is equal to 11 to the power 1 by 4. Okay, so 11 to the power 1 by 2 divided by 11 to the power 1 by 4, this is equal to actually 11 to the power 1 by 4. Okay, and now let us move to the next one. So in next one, here we have we have 7 to the power 1 by 2 into 8 to the power 1 by 2. Okay, so we know this formula: a to the power m into b to the power m. This is equal to actually ab whole to the power m. Okay, so a to the power m into b to the power m, this is equal to ab whole to the power m. So now 7 to the power 1 by 2 into 8 to the power 1 by 2, this is equal to 7 into 8 whole to the power 1 by 2. Okay, and this is equal to 56 to the power 1 by 2. So now let us move to summary. So here we will now discuss summary of this chapter. So in this chapter, you have studied the following points. So first point is what? So first point is a number R is called a rational number if it can be written in the form P over Q, where P and Q are integers and Q does not equal to 0. Okay, so a number R is called a rational number if it can be written in the form P over Q, where P and Q are integers and Q does not equal to 0. And second point, a number S is called an irrational number if it cannot be written in the form P over Q, where P and Q are integers and Q does not equal to 0. Okay, and third point, you have studied the decimal expansion of a rational number is either terminating or non-terminating and recurring. Moreover, a number whose decimal expansion is non-terminating and non-recurring is called irrational number. Okay, so the decimal expansion of an irrational number is non-terminating and non-recurring. Moreover, a number whose decimal expansion is non-terminating and non-recurring is called irrational number. And fifth point, which you have studied, the all the rationals and irrationals number, if R is rationals and S is irrationals, then R plus S and R minus S, they are irrationals number, and R times S and R by S, they are also irrationals number, where R does not equal to 0. And seventh point, you have studied in this chapter, for positive real numbers A and B, the following identities hold. First one is square root of AB. This is actually equal to square root of A into square root of B. Okay. And second one is square root of A by B. This is equal to square root of A by square root of B. And third identity is square root of A plus square root of B into square root of A minus square root of B. This is equal to A minus B. Okay. And fourth identity is A plus root B into A minus root B. This is equal to A square minus B. And fifth identity is square root of A plus square root of B whole square. This is equal to A plus 2 times square root of AB plus B. Okay, and 8th point, which you have studied in this chapter, to rationalize the denominator of 1 by root over A plus B. So here we multiply the numerator and denominator by square root of A minus B divided by square root of A minus B. Okay, so for rationalize this denominator of this, we basically multiply this by square root of A minus B divided by square root of A minus B, where A and B are integers. And 9th point we have studied in this chapter, let A is greater than 0 be a real number and P and Q be rational number, then A to the power P into A to the power Q, this is equal to actually A to the power P plus Q. Okay, and A to the power P whole to the power Q, this is equal to A to the power PQ. And third point is A to the power P by A to the power Q, this is equal to A to the power P minus Q. Okay, and fourth point is A to the power P into B to the power P, this is equal to AB whole to the power P. So these points we have studied in this chapter. Okay, so this is the summary of this chapter. Okay, basically we have studied in this chapter rational number, irrational number and their decimal expansion, and then we have studied about these identities. Okay, and they are very, very important identities. Okay, and then we have studied rationalize of the denominator of 1 by root A plus B, and then we have studied exponential power A to the power P into A to the power Q is equal to A to the power P plus Q, and A to the power P whole to the power Q is equal to A to the power PQ, and A to the power P by A to the power Q is equal to A to the power P minus Q, and A to the power P into B to the power P is equal to AB whole to the power P. Okay, students. So this is all about this lecture. I stop here this lecture. Thank you very much to all of you.